Hey guys, today I want to go over water supplies and flooding, and this will be the last video in this unit. I'm going to follow the slides here. They'll pick up with the guided notes, and as always, you can follow along with the guided notes here, but it'll pick up with the guided notes here in a couple slides. I just want to talk about first the importance of water. Lack of access to clean water supplies can quickly lead to dehydration and death. We talked about some of the diseases in the last PowerPoint unit. And some of the viruses and other problems that are associated with poor quality water. Running water can also quickly erode topsoil, which renders farmlands infertile and streams contaminated. Chemical spills, excess nutrients, and acids dissolved in water can cause massive die-offs. So you can see here by reading just these quick facts and everything else we've learned in this unit that water is extremely valuable and can be damaged easily. So, how is it available for us to use? And we talked about this in the first unit, but again, only a small fraction of Earth's water is fresh water and available for human use. And you can see those figures here. So, how do we use our fresh water? 69% is for agriculture, and most does not reach the crops. Okay, it's used to feed livestock and water horses and cows and things like that. 23% is used for industry, and 8% for domestic and municipal use. Municipal just means by cities and townships. You can see here how several of the larger countries and continents stack up against the world. All right, surface hydrology. Local precipitation leads to surface runoff, ground infiltration, and evapotranspiration, which is evaporation and transpiration at the same time. So the release of water by plants, as well as the drying of water on the Earth's surface. You can see that graphic down here. Let's get into water shortages. What causes these things? Number one, a dry climate. When it's hot, you generally don't see a lot of water. Think about the desert areas. There's not a lot of freestanding water around. Okay? A drought, which is a period in which precipitation is lower and evaporation is higher than normal. Desiccation, which is the drying out of soil as a result of deforestation over grazing. So whenever you see the word desiccation, it just means drying out. And water stress, which is increasing demand for a limited resource. So when a lot of people want something that there's not a lot of, it starts to run out quickly. Here we can see the current water shortages in the United States. So there are some pros and cons to supplying more water. Ways to get it, but certain ways will damage surrounding areas or are expensive. Here you can see some pros and cons for dams and reservoirs. Okay, this will provide water year-round for irrigated crops. Here's something that would consist as a pro. A con would be an example of flooded land destroys forest and or cropland and displaces people. So take a few of those, write them down, just so that you know that each one of these has its own set of pros and cons. Here is just a bigger example of what was just on the previous slide. Okay, so one example of dams and reservoirs is the Colorado River, which is a hot button topic at this point because we're starting to see a lot of the Colorado River dry up downstream, so there's not a lot of availability of water for those lower lying states from where the Colorado River flows. And a lot of the West draws their water out of two places, the Ogallala Aquifer and the Colorado River. And if those two things are overused, then the West will start to go into more of a drought than they already are in. So it's a system of dams and canals, provides electricity and cheap water for agriculture, industry, and cities. And the availability of cheap water has led to wasteful practices for these things. So you get a lot of people watering their lawns when they're not supposed to when you're in a drought, which can cause even more water shortages. But a limited water supply must be divided between farmers, ranchers, cities, Native American, Mexico, and wildlife, because the Colorado River, like I said, flows from the northern part of the United States all the way down into Mexico. So it supplies everybody from the northern part of the United States through Mexico. The population growth in the lower basin is increasing demand of that allocated supply. So again, we come to this supply and demand topic where more people are going to require more water. However, there's not more water coming into the system. So water transfer. You can supply more water. This is the California project. And so here we can see a little bit more. And you can go ahead and write that in here. So the California project, the problem, most of the rainfall is in Northern California, and most of the population growth in agriculture is in Southern California. The solution is water is transferred to the south via dams, pumps, and aqueducts. And the controversy about that is Southern California wants more water for growing cities. Much of the water transferred is wasted by inefficient irrigation, and the north needs the water for fisheries and flushing pollutants out of the San Francisco Bay. So each thing has its own set of pros and cons. Groundwater supplies. Groundwater in the U.S. is being withdrawn at a rate of 4 times faster than it's being replaced. Okay, here's some consequences of that. We can deplete aquifers. I just talked about the Ogallala Aquifer, which is being depleted by the West. The aquifer subsidence land, subsidence land sinks when water is withdrawn. So when you have this water that's in the aquifer, when you draw that water out, the land will then sink down and can create cavities in the top surface. And then you can also have saltwater intrusion, where you'll get salt water from the ocean or at sea level or near the sea level floor that penetrates and replaces where that fresh water moved out. Here we can see some of the groundwater supplies in the U.S. All right, how do we use water a little bit more efficiently? 1, increase the efficiency of irrigation, right? Improve these systems. So things like drip irrigation, central pivot lines, or computer monitoring for these systems. Use recycled water. Treat gray water from showers, washing machines for reuse. Fix leaky pipes. Water-saving toilets, faucets, and shower heads. And xeriscaping, which is to plant drought-tolerant vegetation for residential communities located in arid and semi-arid areas. Arid just means dry, and the definition of xeriscaping is right here, just planting drought-resistant vegetation. All right, flooding. Moving on to the last portion here. Flooding is the result of heavy prolonged rain or rapid snowmelt, which causes water in rivers to overflow its channels. Human activities can exacerbate flooding. Exacerbate means make it happen more, make it happen faster, either increasing the probability of a flood or increasing the severity of a flood. And here there's a list of these human activities I was talking about in the previous slide, and you can simply put them in this area right here. So I'll go through these things: the removal of vegetation, logging, overgrazing, forest fires, mining, urbanization. Take special note to notice that these things are similar to the things that increase erosion. Okay, some more things: the destruction of wetlands, and we can read that here. And then building in floodplains and replacing that vegetation with concrete. Water is going to be able to flow a lot more easily over concrete than it will over vegetation.